In today's sessions, what we will be talking about is Kubernetes. Kubernetes for beginners. Okay, so in this session, because in the last session, what we did was we worked upon backend. Okay, we created our own Docker images. Okay, for backend as well as database. Okay, so as a whole, for container orchestration, okay, in our actual work, we won't be using Docker. Okay, uh, to orchestrate our containers. Okay, so meaning in order to maintain the life cycle management, okay, when we say orchestration, right, it is to maintain the life cycle of our containers. Okay, so this container we can't host it on a Docker or on our laptop. It has to be hosted on a some kind of a orchestration tool. Okay, so currently the number one tool is Kubernetes. Okay, so in Kubernetes, we will try to find it out which one is the um we'll try to find it out for the beginners what all the things it is required. Okay, so those all the things we will try to uh, learn about in today's session. Okay, so as I mentioned, so in today's session, we will go through introduction to Kubernetes, why Kubernetes, and understand the main Kubernetes components such as pod, node, pod, services, config map, secrets, and deployment. Okay, these are all the building blocks. Okay, any application, in order to bring up any application, right, we require all these Kubernetes resources. Okay, one by one, we will try to understand each one of it. Okay, and then we will go ahead and run this particular one by one resources on our minikube clusters. Okay, as a practice, how exactly we need to do that, we will run it in a using Kubernetes CLI commands. Okay, so once it has been done, we will go through the YAML deployment. How using YAML, how exactly you can deploy the same number of services. Okay, so let us start. So what is Kubernetes? So in Kubernetes, right? So it is a number one orchestration tool. Okay, it's a open source. First thing is it's open source. It's free. Okay, so it is being used for deploying and scaling. When I say scaling, right? So uh, you have a less load currently. Okay, so think that there were due to your application or your project becomes very popular and many people try to access it. Okay, so in order to sustain the load, right, you need to scale your application. Okay, meaning earlier if it was a one virtual machine, if it is running, you need to make it as a 10 because the load has increased. You don't want your application to be slowed down, right? So that is the reason we scale it, meaning we increase your in number of instances of same application to multiples so that it can withstand the load. Sorry. So in order to, I mean, why and Kubernetes was a little bit background about Kubernetes. So Kubernetes was open source around 2015. Okay, but it was built by Google. Okay, so its predecessor in Google was a system or a project called as a Borg. Okay, so that is literally battle tested over the decades in Google. Okay, so Google was extensively done the testing on the Borg system. So when Docker became a popular, right? So obviously, in order to orchestrate, meaning in order to maintain the life cycle of our deployments, our application, right? In order to make sure our deployment is successful, auto scaling it will happen or not. So in order to do that regular activities, we required a one orchestration tool. So Google was already has built this. Its successor was a Borg system. Okay, it was battle tested. It had all the features. Okay, so it was up and running when Google was uh, Google was using the Borg system from beginning. Okay, so it has all the features. So around 2015, because of Docker became so much popular, right? Many people started moving to containerization. So during that time, what Google thought was, let us open source it. Okay, so what they did was they got few of the engineers who worked on the Borg system, and what is the required bare minimum required in order to orchestrate the containers, right? So those are all the features. What they did was a lift and shift. They did it and created a project called as a Kubernetes. Okay, so that Kubernetes in 2015, Google made it as an open source because it was already battle tested. It had all the features, and it was able to, all the community was able to adopt Kubernetes. Okay, because of these bit. So even the Docker made it as a popular, made it as popular. Okay, but Docker had its own another product for a orchestration of a containers called as a Docker Swarm. Okay, but they were building it from the scratch. Okay, the features were not at all ready, and it wasn't up to the mark. Okay, so Google, when it outsourced the Kubernetes, right? So it is a survival of the fittest. So Kubernetes was in a top notch. It had all the features. It was able to survive, and it was able to thrive basically. Okay, but whereas the Docker Swarm, it slowly died down. Okay, the product required um, if someone wanted to use a Docker Swarm, so they have to pay the enterprise license. Okay, they could not, people could not pay for it, because when already a Kubernetes is freely available, why people want to go for a paying Docker Swarm? Okay, that is the reason Docker Swarm has died down. The product itself has been slashed, right? So now Kubernetes, why it became a popular was it had all the history of Borg system, right? So all the features were already included in this Kubernetes. Okay, so in order to do a deployment of application quickly, and if you wanted to scale it or increase the replica set to 3 or 10 or 100, it can do it immediately, and you can predict it. Okay, so on the fly, with a change of one application, you can scale it out. Okay, rollout of the features, it was easy, and it was using a limited hardware usage. It was there. Okay, it was using it. Okay, so Kubernetes, the name itself, it is originate from the Greek word. It's a helmsman or a pilot. Okay, if you see the symbol of Kubernetes, it is a uh, it's a it's in ship, in order to direct the ship, right? So ship, right? So we use that, but that is the logo of Kubernetes. Okay, and sometimes we call it as a Kubernetes as a K8. Okay, so the K8 is basically, when we say K8, right? K is from the first letter, and the other are 8 letters, and next one is a S. Hence, we sometimes call it as a K8s as well. Okay, so if someone asks you, do you know K8s? So it is nothing but, do you know Kubernetes? So why Kubernetes? It was already, when you can have a authentication authorization. Okay, naming and discovery of service was a bit easier. Okay, so you wanted to have a load balancer with a few configuration. With the service, you can enable your own load balancing. Okay, you can have your application health, auto healing part, or horizontal scaling. You can do that. Okay, mounting is also easy, and in order to store your credentials, you can use secrets. Okay, if you wanted to keep in any configuration, we have already a config map already available. Okay, so in order to triage your application, you can, using Kubernetes logs, you can check your logs inside the container as well. Okay, so it was bit easier. Okay, so Kubernetes, you can deploy Kubernetes on any physical server, virtual machine, public cloud, private, or a data center, or even on your laptop. Okay, it is bit extensible. Okay, so in olden days, what we had was a in say 10 years back, if there was any issue on of our application, right? Application is deployed, and due to some reason, due to space issue or some reason, if application is unable to perform, right, or unable to uh, work itself, so during that time, a L1 or L2 engineer will be called, and the engineer, if it is whatever the time it is, right, the engineer is to go there and fix the issues and probably restart the application itself. Okay, but whenever it has been called, during that time, there is a outage will be there, right? And the person has to be called in. Okay. So due to whatever the issue of the application, though he is doing a manual restart itself, then also the person has to go and log into the um, virtual machine and do the needful. Okay. But in Kubernetes, you can configure it. If there is any issue, automatically pod it will get auto restart. Okay. Or if there is a scaling issue is there, when there is a hell lot of load, depending on that one, you can auto scale it as well. Okay. So these are all advantage of Kubernetes. Okay. So main component of Kubernetes, it is main bit is heart and soul of our Kubernetes is our APIs. Okay. API controller. So in that one, whatever the request it is coming to Kubernetes, it goes to API controller. Depending on the request, what API controller does is it will send a request to either scheduler or config manager or a cloud control manager. Okay, depending on the request, it will go in. Okay, it will send the request and get the work done. Okay, so etcd is a database. Okay, so in Kubernetes, most of the time, in say probably in 2008, 18 and all, so we may need to deploy our own Kubernetes cluster. Okay, but that was a bit difficult as well as in order to maintain all these API servers, backup you need to take, or if you wanted a node, you need to go and manually add it. Those all the extra headaches were there. Okay, in approximately 2018, right? So then each of this cloud providers, CSPs, they came up with their own version of Kubernetes service. So, for example, we have 1 second. So, each one came up with their own services. Okay, so if you could see here, so Amazon came up with their own EKS. Azure came up with the EKS. GKE came with, I mean, Google came up with the GKE, Google Kubernetes Engine. Oracle came up with, OCI came up with OKE. It stands for Oracle Kubernetes Engine. So due to popularization of Kubernetes, right? So all the CSP providers started giving their own version of Kubernetes cluster. Okay. So mainly in our Kubernetes, we have a control plane, and second one is a nodes. Okay. So any containers we run it, right? In in Docker, any containers we run it, right? So we send a request to API controller. API controller, what it does is it selects a node. Okay, a node is you can think of it as a virtual machine. Okay, inside that one, a container will be running it. Okay, so this control plane. So why I brought up the CSPs, right? AKS or EKS or OKE. So after 2018, right? So before 2000, I mean, around 2018, we used to deploy our own admin server, this control plane, as well as the nodes. Okay, if you wanted to add a node, there were a couple of steps were there. You wanted to drain it out, there were manual steps were there. Okay, so we need to do it manually. But because of popularity of Kubernetes, so everyone started selling their own services. Okay, so what they did was, so they had asked all this admin control headache, they took care of it. Okay, they have taken care of it. So if you need not, I mean, you need not manage API server database, you need not take a backup of database, right? So these all the things is controlled by service provider itself. Okay, so node also, you need not patch it, you need not bothered about any of the installation. If you want a another node, you just send with a couple of configuration change, you can go for another node itself. Okay, so if you wanted to increase the nodes, so in this control plane, actual workloads, that is our application, right? It won't be installed on a control plane. It will be installed on a pod. Okay. So the containers what we run is inside the node. Okay. You can think of our containers as a parasite, which has in order to which will depend on this node's resources in order to run our containers. Okay. So what you need to remember is our containers which we are running, right? It will be running on our nodes itself. Okay. How the request will flow in basically, sorry, the request will be forwarded to API controller. API control will facilitate which node has a capacity, and the containers will go and create it over there. Okay. So roughly, this is what the diagram it looks like. Okay. So a cloud control manager, since we are using a measure of cloud control, the services of EKS or extended version of our Kubernetes, right? So we would be using cloud control manager. When exactly this will be used is, so think that you wanted another virtual machine, or if due to some reason this node goes down. Okay. So API server will be keep on pinging these nodes. Okay. If it is unhealthy, then API server will send a request to cloud control manager. Okay. That cloud control manager, depending on this Kubernetes cluster where exactly you have created it. If you have created it in Azure, uh, we will what it will do is cloud control manager, it will interact with that cloud and get us the replacement for this particular node. If this node is faulty, it will get you another node. Okay. Similarly, if you wanted a load balancer, okay, for the service you have made it as a uh, load balancer. Okay, so you wanted a node load balancer. In that case, API server will send a request to cloud control manager that will provide us a uh, the requested resources. Okay, so this is on a high level, it's the same but okay, cloud control manager, API server. So any request it is coming up, it will be served by a nodes itself. On the node, our containers will get hosted. Okay. Coming back to on a node, so there are two processes are mainly run, that is kubelet as well as kubeproxies. So as a whole, you need not bother if you are using any of the uh, service providers Kubernetes clusters, then you need not bother about either control plane or a node. Okay, you need not bother about it because you are not working on those nodes itself. As a maximum of the 80% of the time, you will be mainly responsible for to deploy your application or scale your application. Okay, only that level of a interaction you will be doing it. Okay, on a Kubernetes cluster. So yeah, so a little bit brief about the same thing. So as I discussed, Kube API server, it's a component. uh, it exposes the API. Basically, it's a front end for our Kubernetes cluster. Whatever request it is, we sends it. Any small command, if I say create this particular container, okay, the request will be gone to our API server. That itself, it will create the next step. Okay, etcd is a database. Okay, whatever these bits are there, right? So as I said earlier, if it is only if you're working on a data center Kubernetes cluster, then only you should be bothered about knowing about all this. But as a whole, right, in some of the interviews, people will ask how you take a backup of a etcd, right? In the actual world, you won't be doing it because it is all taken care by the cloud service providers. Okay, but major of the cases, if you wanted to clear any certified Kubernetes administrator, right, during that time you may need to perform these tasks. Okay, or if your Kubernetes cluster is installed on a data center, then only you need to bother about all this terminologies, what exactly it does and all. Okay, this is only for a knowledge sake. Okay, or uh, to crack the interviews, right? So yeah, people will ask in the interviews what is this and all. Yeah. So Kubernetes etcd is it is highly available key value store, meaning our request, whatever request we send it, right, everything it is logged and audited on this particular database. Whatever request we make it, it will be entered in this particular database. Okay, so Kube scheduler, it's basically responsible for it when you schedule when you ask Kubernetes that create me this particular pod, it will check the nodes. Okay, so in which node there is a space is available, okay, where exactly it is full, it will try to find it out the feasibility where exactly this particular node has to go and sit. So that is the responsibility of our kube scheduler. You can have affinity, anti-affinity, if there are any hardware requirement, if you have it. So if you think that your container requires lots of memory and all those things, right? So during that time, we will, since containers are kind of a parasite or runs on a node, okay, kube scheduler will find out which node has that much of memory, asked memory, right? So depending on that itself, it will schedule that particular container creation request into that particular node, on that particular node. Okay, so yeah, so kube-controller-manager. Okay, there are four types of responsibilities are there. Node controllers. If it is goes down, it has to it will feedback the API server. API server will contact cloud control manager. Okay, so job controller, if there are any task, it has to be one of task, it has to be created, right? That will be done by our kube control manager. Okay, so if there are any endpoints are there, services, or the joining our services to the pod, right? Using endpoint controller, kube control manager does the work. Okay, even till 1.24 probably, yeah. So whenever you used to create a service account, right? So service account is a, you can think of it as a uh, service user. So any application, right? Any in a Kubernetes cluster, we can have n number of service user. In let us take one example. Okay, so in a database, right? So probably you will create one root user. Okay, and then thereafter, if we have a 10 application, okay, and 10 application require its own databases. Okay, so in one Oracle database, you will create a 10 schemas. Okay, that schemas, one schema, we will give it to one project. Okay, in order to access that particular schema, we should have a 10 different username and password. Either we call it as a service user. Okay, those users we will give it to the respective application team, right? So with that account only, they should be able to access their particular schema. Okay, similarly, the service account concept is in Kubernetes. So in what we do is we create a namespaces. Okay, a logical separation within the Kubernetes. Okay, so one, if we have a 10 project has to be deployed on a one Kubernetes cluster, so what we do is we will create a 10 service account. Okay, one service account is linked to the one project. Okay, in that service account will be we will mention which role that service account has to be associated. Okay, role is basically on that particular namespace, how exactly, what all the permission that this particular service account has, what it can create it, what it can view it, right? So what all the resources, Kubernetes resource it can create it. So we will attach service account with a role. Okay, service account will be given to each particular project. Okay, so in previous version of Kubernetes, okay, especially on the AKS cluster, okay, default service account was created. Okay, even the password it is kept it in a secrets. Okay, but the latest version of Kubernetes, that it has been deprecated because people doesn't want when the default secret should be kept it in a secrets, in Kubernetes secrets, so that if someone gets access, get holds of those accesses, right? So it is a bit difficult, right? So they can get a control over the that particular namespace itself. That is the reason this service account in earlier, say 1 year back or a couple of years back, account was created with the password itself. Okay, so Now, now it is only it creates a service account. Password, the person itself or admin uh, account itself should be able to create and give it to the respective project. Okay, so the creation of this service account and token controls, everything it is handled by a control control manager. Okay, as I explained earlier, cloud control manager, if anything happens with the node has been deleted, then uh, it is responsibility of cloud control manager to get the new new node. Okay, so routing control, root controller, so setting up of the routes, how exactly egress or ingress has to happen and all, it will be maintained by this bit. Okay, service controller for creating and updating our load balancer, as I earlier explained, right? So if you want a load balancer, then in service you will mention type equals load balancer. So then at that time this particular uh, task or scheduler will come into picture. This particular component will come into picture. Okay, so on Kubernetes node, that is a main bit. Okay, in that one itself, all our application runs. Application in the sense as a container, it will run on the node itself. Okay, if you have a high end of a node, okay, then you will be uh, able to host that kind of a containers itself. Okay, so mainly kubelet and kubeproxy is installed on that particular node component. Okay, what is kubelet in on the nodes, right? So it is an agent, automatically runs on the node, on the specific node itself. It makes sure that containers are running on inside our pod itself. Okay, depending on the what the specification we provided inside our pod specification, right? So that it will make sure a kubelet component will make sure that containers are running in the respective pod specs itself. Okay, uh, next bit is kubeproxy. It is a network layer. Okay, so each depending on in AKS, right? So we have a different types of uh, s- container network interface, right? So you have a Kubernetes or a uh, Azure CNI, Azure Container Network Interface. Okay, in Azure's container network interface, we have further overlays there. There is a there are few more things are there. Okay, so as we go along, right, we will I will try to explain about the same thing. Okay, so it is mainly used to communicate. Okay, communicate between a pod to pod. Okay, uh, a network in between, talking between a pod to pod, right? So if you have two pods, okay, it has to talk to with each other. So this is what kubeproxy allows. It makes sure that our network policy or network rules running on properly. Okay, it maintains that bit. Okay, so yeah, so the next bit is a container runtime. Okay, it is a software. It is required. It is responsible for running our containers. Okay, you could have heard about Docker. Okay, Docker is a container runtime engine. Okay, that is the which is responsible for running the containers. Okay, so here apart from Docker, Docker has its own competitors as well. Okay, Containerd or CRIO. Okay, but these are all not that much popular compared to Docker. People know about Docker. Okay, so until probably last 6 or 7 months back, until that one, Docker was the default choice of Kubernetes to to run our containers. Okay, but Kubernetes moved away from that and it has left to the user, that is whoever wants to change this container runtime, they can choose whichever they wanted. Okay, the customer. So Kubernetes left it to with the its choice of a customers. So which container runtime people wants it. Okay, so this is the one flow diagram of our how exactly if I ask Kubernetes API, right? Kubernetes, if I ask one, create one container, okay? So this is the flow of our running up of containers, okay? One second. So when I say, when I run a one container, okay? So if I say run this particular container, so let me give a one example itself, okay? So when I say create a pod, the request is gone to our API server. Okay. So then what will happen is API server will send a request. It has to be audited. Okay. The request will be written on a etcd. This is a database. Okay, Kubernetes database. So it will record it saying that okay, so and so person has asked to create our pod in such a way. This the image the details, it will mention it here. So once asynchronously the request is came back to the API server, right? So our API server will send a request to our schedulers. Okay. So once we get the information, okay, where exactly that particular uh, node it has to be added, which it has to bind which pod. Okay, so the request will be for when response scheduler will respond to API server. So API server again sends a request or audit it or make an entry into etcd database, okay, saying that okay, this is the pod, it will go and create it there. Okay, so then what API server will do is it will send our inside our particular node, right? It will go and deploy our pod. Okay, so that on that particular node, this is on the node. Okay, this side is a of our node, Kubernetes node. Okay, so once the request is received by the Kubernetes node, right, it will it will talk to container runtime, which is running on that particular node itself. Okay, it will ask Docker to, in this case, in this example, it will ask Kubelet will ask Docker to create a container for us. Okay, once the container is created, okay, then the request will be forwarded to our API server saying that okay, what is the pod status? It can be failed status, it can be created status, right? So that will be again returned into etcd database saying that okay, this was the request. Okay, now the pod status is so and so, either it is failed or image pullback error, whatever the error it is there, right? It will be written in the etcd. So in this way, the life cycle of a one creation of a pod, okay, these all the things it will happen. Okay, so the Kubernetes, if I okay, so the next bit is the Kubernetes node. Okay, as I said earlier, what is node? So it is a virtual machine. Okay, it's virtual machine or a physical machine. Okay, where our pods runs. Okay, pod. So there is a in Kubernetes world, in Docker world, a single smallest deployment unit is a container. Okay, in Kubernetes world, a pod is a single smallest deployment unit in terms of a single deployment unit, the smallest deployment unit. Okay, the pod, inside the pod, right, our container runs. Okay, in Docker world, container runs on its own. Okay, in the Kubernetes world, container runs inside the pod. Okay, that is the point to be noted. Okay, uh, node, on the node we run the pod. Okay, pod will run on top of the our Kubernetes node. Okay, so inside the pod a container will run. Okay, so and the nodes will be managed by API controller, our control plane, right? So as I said earlier, pod is a smallest deployment computing unit. Okay, it can contain one container or more than one container. Okay, so usually we go for normal standard is most of the pods will be running one to one container, one pod, one container is running. Okay, in some of the specific cases, okay, so we will be running a second container inside the pod itself. Okay, each pod will be having its own unique IP. Okay, by default, one pod is deployed on a particular namespace. It can communicate it to all the pods inside that particular namespace. Okay, so this is on the in the next session we will be talking about the YAML deployment, how exactly YAML will be used. Okay, uh, we will talk about the basic now, and then we will move on to the practical bit of it. Okay, so Kubernetes service, it's basically grouping of the pods, okay, based on the our selector criteria. Okay, so any cricket team, right, or any team, any football team or any soccer team, right? So that soccer team is given a name, right? So if you ask me, India team, right, India cricket team, if you say that it consists of a whatever the playing 11 members, right? So when we say service, right, so if I say India team, so current stage Rohit is our captain, right? So that comes into our head, right? So similarly, when we say services, right, service, we will call the service. So any request coming from the outside, right, the naming, we will have a service, we will call to the service. Service will be having one or many pods. Okay, best example is, so the name of the team, right? So that is, you can call it as a service. Okay, inside the team we will be having number of players, right? The similarly here, number of pods. Okay, if you wanted to address it, we will call it as a Indian cricket team, right? The similarly, if you wanted to access that particular pod, we will call the service. Okay, service is a group of number of pods, okay, based on the selection criteria. Okay, so that is over here. Okay, so this is the example. Okay, so if I say services, right, so if someone wants to access Nginx service, this Nginx service I have taken a one naming. Okay, so Nginx service, so if you see, it had selector called as a key and value called as a app and proxy. Okay, so service is another Kubernetes resource. Okay. Here, what we will mention, selection criteria for this particular team is, it all the pods should have this app equals proxy. Okay. So if you see the label, this particular pod has app equals proxy, right? So this, if it is a different version also, okay, here if you see there is no version, meaning latest. If it has a Nginx has a 1.5 version, okay, but the label, if it has a same as the service, right? So any request, anyone is accessing this particular service, the request will be forwarded to either this or this. Okay, at a given point in time, the request can be served by this one or this one. Okay, other than that one, no other, pods. Okay, think that this particular pod is also Nginx service. Okay, but its label is proxy 2, it has been mentioned. Okay, then this service, though it is a Nginx service, okay, it has a app equals proxy 2. Okay, it's not a proxy. Okay, it won't send a request to here. Okay, this whatever the request coming from here, it won't send it to this particular pod, because the selection criteria has been not met. Okay, that is the reason it will send only request to the labels, the pods whichever has a label same as our selection criteria. Okay, that is what the use of services. Okay, so I'll quickly take a config map. Okay, before going to the config map, right, so we have around 20 minutes. What I will do is I will try to cover this bit in the next section as well. So next session as well. So now what we will do is we will quickly go and create a Kubernetes practical pods. Okay, and we will create few of our services as well. Okay, let us go to our website. Okay, so in order to create Kubernetes, right? So let us travel back to the kubernetes.io. Okay, the way I teach is which is already readily available over the internet. Okay, so Bible for Kubernetes is our Kubernetes documentation. Okay, so you should make sure that if you have any doubts, there are a hell lot of examples are available. Okay, you need to make sure that you use those. But okay, if you I will explain you how exactly you need to search and how exactly you can create your own resources. Okay, so now I will say uh, Kubernetes. Let me say cheat sheet. Okay, if you go to here, okay, uh, you wanted to before that, so let me see. And okay, so before going further, so what I would suggest you is, in order to practice, right, in order to practice on AKS cluster, what I advise is to install a Minikube cluster on your laptop. Okay, Minikube is a free version which is available on your over the internet. You need not pay or install any Kubernetes cluster over the cloud. Okay, so that you, in order to learn it free, right, what you could do is install Minikube on your laptop. Okay, I've created a couple of videos, okay, on how to install it on Windows laptop. Okay, I will link it to the this particular video. Okay, so try to install Minikube cluster rather than paying for a cloud, right, or creating a AKS cluster or EKS cluster. In order to practice on Kubernetes, you can run most of the commands on Minikube cluster. It's fairly easy. Okay, so first command is, in order to increase the font size. Okay, so in order to Minikube cluster is a single small cluster, mini version of Kubernetes cluster. Okay, so if you wanted to check the node, how many nodes are present, what you could do is kubectl get type node. Okay, you would be able to see kubectl get node. So there is a one single node is present. Okay, so Minikube contains a control plane as well as a single node on a single virtual machine, single small virtual machine itself. Okay, you can run Minikube on a Docker itself. So I'm currently running our Minikube cluster on a Docker itself. Okay, so you can, in order to find it out, the nodes. Okay, so you can type kubectl get node. It will mention the status of it. So currently it is ready. So if you wanted to see further details, -o wide, you will be able to see further details of this particular Minikube cluster. What is the internal IP? What is the OS? Okay, and where exactly it is running. Okay, it is currently running on my laptop. That is the reason it is showing those details. Okay, so now if you wanted to see how many pods are running, okay, you will say kubectl get pods. Okay, if you see, it says no resources found in default namespace. Okay, so uh, in order to check this, you can do kubectl get pods. Okay, or get a pod or get a PO. Okay, all these things, it will give the same result. So in order to reduce our time, so we will try to use the short name of our pods, that is PO in this case. Okay, so now let us go and create a one Kubernetes cluster. Okay, sorry, one Kubernetes pod. Okay, so the simple command, this YAML bit, I will try to explain it in bit later. Okay, so I will go to here. So the command is kubectl run. Okay, so I will go here. I will say run kubectl run. Okay, so you wanted to run our Nginx server. Okay, so if you wanted to run that, what you will say, kubectl run Nginx. Okay, Nginx is the name of the pod you are trying to give it. Okay, I don't want to give a namespace as that. Okay, this is the name of a Nginx, so I will say beginner Nginx. Beginner Nginx. Yeah, beginner Nginx. Okay, Nginx. Okay, and I will pass the image name. Okay, if I say that, what it will do is it says a pod beginner Nginx has been created. So let us go and check it. Okay, if I say kubectl get pod, you will see my nginx has been deployed and it is running. Okay, the name whatever I gave here, it is what it is displaying over here. This image nginx is there, right? So it is, what it does is, if you won't mention a version, it will go to Docker Hub and gets a latest one. Okay, this image resides in a Docker Hub. Okay, so if you search nginx, this is the one. It will go and download this particular version. So that is the latest. Okay, so you wanted to see it, what exactly it has been mentioned over here. Okay, so I will say kubectl get, okay, or describe. Okay, describe is used to describe your pod. Okay, and I will enter describe. PO stand for a pod. I will say that pod name. So if you see here, it has a details. 1 second. It has the details. So if you, the image is this one. Okay, where exactly this particular is picked up, the nginx is this particular image. Okay, so let us see it. This particular nginx, it has been picked up. Okay, so the status, it will show you whether it is running or not. Okay, and what all the events it has happened. Successfully assigned a default beginner nginx to minikube. Okay, pulling the image. Okay, successfully pulled the image. Okay, and created a container and started a container. Okay, so here if you say get the pod, right, here it will say one of one is ready. Okay, the first is the name of our pod. Okay, second one is whether how many containers inside it is running. Okay, it is currently one pod has one container. This nginx pod, this pod has a one nginx container running. Okay, the status, the name itself suggests it's a whether it's running, failed, those bit it will mention it out. Okay, if due to some reason it gets restarted, right, that is what it will display over here. Okay, so currently the age of this particular pod is 2 minutes 3 seconds. Okay, so this is the details about our nginx, current nginx it is running. Okay, so think that you wanted to download your own version of nginx. Okay, so I have downloaded my versions in our academy. Few of the application I have installed it. Okay, so let us see. This is our beginner academy versions. Okay, so I will choose 1.4. Okay, I wanted to deploy my own image which is present in Docker Hub. Okay, the command what I use is kubectl, okay, run. Okay, I'll say mine, or I'll say ba pod. Okay, ba pod. Okay, and then minus image equals to this particular image. Okay, beginner academy ba minus nginx. Okay, I'll mention the port. Okay, port it has to run on 80. Okay, I will say this bit. Port 80. Okay, so I have given a port it as 80. Okay, what I have mentioned is my this ba pod has to be running on a port 80. Okay, so if you see, pod ba pod has been created. Okay, how do I check it? I will say git kubectl get po or pod or pods. It will show me my ba pod has been running from 24 seconds. Okay, so now I wanted to access it, what exactly it is there. Okay, so for that what we do is we will run a command called as a expose. Okay, so let me type it, expose. Okay, I'll take the command. Okay, so this, what this expose does is it creates a service for us. Okay, so if you see here, I will say kubectl get a service. Okay, if you say get service, there are these many services are present. Okay, so services you can do service as well as svc. Short command is svc. Okay, so if you run this, you will see all the service present. Okay, so our command, expose command, what it does is it creates a service for us. Okay, so let me copy this, but let me type it out. What is, I will type, it's okay, kubectl. I wanted to expose my pod. Okay, which is ba pod. Okay, so I will say expose pod ba. So if you see, our ba pod has been exposed. Okay, if I do get svc again, you will see ba pod, a service that has been created. Before that, only 3 were there. Now the ba pod, it has been created. Age you can see 6 seconds. Okay, so now you wanted to access your pod. Okay, accessing of a pod, it is always done by a service itself. The example which I took, right, that a cricket team, you will call, he belongs to specific country cricket team, right? So the similarly, in order to access it, you require a service. Okay, so if you see here, this particular service is having running on a AT port, which will interact with our pod. Okay, so now I wanted to access my application, which just now I've deployed. Okay, I will say port forward. Okay, yeah, I could have run as is like this. Port forward, I'll say svc and a pod. Okay, so this is application is running on 80. I'll say 7080. This is my port. Okay, which will interact with 80 port. Okay, so this should enter. So if you see, a port forward is a creating a tunnel. Okay, that is from my local laptop, that is on this port. Whatever request I will do it, right, it will forward it to service. Service will forward it to the pod. Okay, in that chain it will happen. Okay, so let me go and access my application now. Okay, I will say the port which I gave 7080. Okay, so let me say 7080. Let me remove this part. Okay, so let me access it. So if you see, it said welcome to demo session. If you guys can see, this is the container running inside my Minikube pod. Okay, so if I wanted to see it, it's basically kubectl get pod. Okay, I wanted to check the logs. Okay, logs minus f, pod is our a pod. Okay, I will enter it. Okay, so if you see here, I will show you directly. So I have entered it so many, so I will refresh it. If I refresh it, you would be able to see a request. Okay, so I will maximize this bit again. So meaning the request is served by our container itself. Okay, I have done a logging inside the container. Okay, I'll do refresh. So if you see, an entry has been made. Okay, meaning our application is responding. Okay, so think that I have another version. Okay, so 1.4 is there. I wanted to access 1.5. Okay, so I wanted to run another application called as a 1.5. My same command. Okay, same container. Okay, so what I will do is I will pick up the same code. Okay, same command. Okay, so I will go back to another window. I'll say kubectl will give 1.5 version here. I will say 1.5. Okay, So then this is the name of the pod. Okay, image is this bit. Okay, it will be running on port 80. If I run this, okay, same mistake the last time what I did. So I'll say port. Okay, it's expecting, I cannot give it as a dot and all. I will say dot 5. So if you see, it has been created. Okay, if I say kubectl get pods, it is still creating it. Give some time. If you see, I could see our pod has been up and running in 11.5. Okay, so let me try to expose it again. So expose. So or I can do the port forwarding as well. I will forward to my pod itself. Okay, if I wanted to access my pod itself, so I will say this is my port forward. Okay, this two applications are running. Okay, port forward to BA pod. This is 80, okay, which is a container port. So 5000 is the way I will access it. Okay, so I will go here. I will go back to here, localhost. I will say 5000. If you see, uh, the data it is displayed here. Okay, a newer version also I'm able to access it. Okay, so that's it for today's session. What we will do is this example we developed this particular application, right? The front end, back end, and DB. We will be trying to deploy it on a minikube cluster in the next week. Yeah. If you like this particular session, just hit the like button or add a comment. Okay, that would be much appreciated. Thank you very much. See you. Bye bye, guys.